Okay, let's get started. We finished with arrays last time, and this time we're going to talk about more arrays. But we're going to apply arrays to list and string concepts and talk about string class. This lecture is, I believe, number 16, and it goes through a lot of stuff. But I'm going to kind of skip through some of the stuff that we've already covered, and you can go back and look at that in more detail. Because we already talked about enumeration types already. So I'm going to kind of thumb through here. But you know what this example is really good for is it provides, or this lecture is really good for, it provides examples. So in terms of how to create an enumeration, which we have already looked at, it gives you the syntax, but it also gives you some examples in terms of defining a couple of different enumerations. And one of the things I haven't mentioned, or I don't know if I have mentioned it yet about enumerations, is that these internal values, this blue, brown, red, green, yellow, can't be used in another enumeration. So you can only have unique item types inside of the identifiers, I should call them, inside of the enumeration declaration. So you can't have two enumerations with colors in it using the same colors, which is one of the limitations, but rarely would anyone actually even come into that problem, usually.
Can we have the same enumerated name?
You can't have the same enumerated name either. Huh?
The orders of it doesn't matter the orders of the colors vary.
That's correct. It doesn't matter if the order's different.
But when the program is performing,
yeah.
What enumerated value will you take? If you have colors, enumerated colors, brown, black.
Oh, it'll take on the value of its index. So 0, 1, 2, 3. Did I not hear the question? Or?
No, I was just taking starts from 0.
Yes, starts from 0. It's very similar to an array, actually. Actually, we'll just use this one here. Instead of using, let's say, numbers, you're using characters to represent numbers. So you can remember A, B, C, D, E, F.
My question here is like, I'm using another enumerated value called grades.
Uh-huh.
But the order of the grades is B, C, A, D.
Oh, no, you cannot do that. Yeah. You can't duplicate any of these names. Any of these variables here that you have cannot be a member of any other enumeration. And you can't reuse the name either, which is interesting. Why? Because usually, well, actually, it's sort of like an array, but not implemented as an array. And so the compiler keeps track of each one of these as single values, believe it or not. It just, the enumeration allows you to organize them for easy access and for remembering them. But essentially, you're creating like 1, 2, 3, 4, 5 different single variables of character type. And it's representing 0, 1, 2, 3, 4. So kind of primitive, actually. So there are some limitations. And what do we have here? Illegal enumeration types, more than one value in an identifier. So like it's going to give you a problem. Let's see. Declaring variables. We know how to declare variables, assignments, the statement. This is enumeration variables. Let me skip through this enumeration stuff. Relational operators, we know about this stuff. We talked about this already. Something equals something, something less than, something more than. We know how to loop through. We've seen some examples on that as well. But if this is brand new to you, go back and take another look at this particular lecture. What I want to get to is the string stuff. So let me find it here. Anonymous data types. Type define. Have we talked about the type define? I think we did. I think we also covered the type define in this class as well. String type. This is where I wanted to start, actually. This is why I brought up this lecture. Okay, so to use a string type, you have to include string.h. We have all done that, but what I want to do is kind of compare strings now with arrays, because last time we talked about arrays, multiple dimensional arrays, and single dimensions, and subscript values, and everything. And I mentioned before you could create a character array and call it a string. And what ended up happening is people, obviously did that, and then they created a string class, and the string class is implemented by an object that really is a character array. And so we have a bunch of methods that we can run on the string class that gives us more automation. So when we declare a variable, we don't actually use arrays here at all. Instead, we include the string class, and the statement string name is equal to William Jacob. It automatically creates it for us. So it declares a name of a string variable and initializes it to William Jacob. And the position of the first character W in here is 0. And we have 1, 2, 3, 4, 5. So we can actually kind of treat this like an array.
Can you display in the individual letters like name of 0?
Name, and then right here you put the brackets and you go 0 and you'll get a W.
That's
So you can use a string, and I have some examples coming up of that actually. So you can use a string as an array of characters and vice versa. And so the binary operator, the plus, can be used because it's overridden in the string class. So it uses for concatenation operation. So the array index subscript operator, this one here, has been defined for the data type. As an example here, so suppose we have the following declaration: string 1, 2, and 3. And the statement string 1 says hello there, stores hello there in string 1. The statement string 2 is equal to string 1 copies the value from string 1 to string 2. So we can do assignments in terms of any other variable that we might have. And then we can say string 1 is equal to sunny. That's the statement. So string 2 is equal to string 1 plus day. So the plus symbol, you would think you'd get an error message, but with a string class it's overridden actually to do concatenation instead of addition. So we can actually use that operator, which is kind of an example of operator overloading that you can actually do in your classes as well. So an object of a class can be added to an object of another class or something of that nature. And stores the string sunny day here as string number 2, because we have sunny plus day. Now if string 1 equals hello, string 2 is equal to there, we add those together, we get hello there. So the statement is equivalent to the statement here. So we're just using concatenation to put things together. And here's what I mentioned before, there's an example of it coming up. So we use it as an array. So the statement string 1 is equal to string 1 plus Mickey. Updates the value string 1, appends Mickey to the end of it. So if string 1 is the hello there, then string 6, 0, 1, 2, 3, 4, 5, 6. Well, it's actually lowercase t, it's not uppercase t. But if you wanted to say make it equal to t, so we made it equal to t, it replaces t, the lower t, with a capital T. Interesting. So we took a string variable that we declared using a string class. Now we've turned around and used it as a character array. Interesting. You can do the exact opposite. You can take a character array and use it as a string. However, if you declare it as a character array, you don't have access to the string methods because it's not an object of the string class, it's character array. And we'll see in the next couple of slides, and here's a couple of them right here, we can use methods. So the string variable that we created using the string class and the data type string created an instance of an object. We run the methods and we run the functions that are associated with that particular object. And we can do a lot so sophisticated data manipulation without having to worry about the character array. So here's the data type string that has a data type associated with it. And so string size type and the name constant string number of positions associated with it. So size type is the unsigned integer of the data type. Number of position gives us our maximum data that's going to be stored in terms of number of positions for that particular data type. So we can have, and these are just different data members. The member functions associated with it, one of them in example would be length. So just like we've taken, and we create a variable of any, we create an instance of any object, and here we have string variable. We can go .length, which is we're running a method essentially on that instance of that object to get the length. So the length function returns the number of characters currently in the string, and the value returned is an unsigned integer, and the syntax to call it is right here, .length. And so where string is a variable of the string type. So the function length has no arguments associated with it, we're just asking for the length in terms of the method call. So here we're using a variable like an object. We're running a method on an object. And the string variable is one of those things that ends up being an object and a variable at the same time. So consider the following statements here. We have string first name, string name, string. First name is equal to Elizabeth. The name is equal to first name plus Jones. String is equal to it is Sunny. So we have the statement printed to the screen, first name.length. It's going to print 9. Name on the name object is going to print 15. This one's going to print 12. So we see that so far. So kind of gives you an idea about the power of each one of the individual objects, instances of those objects that's created. Now the function length returns an unsigned integer. We can actually add it or assign it to an integer value, length. So the value return can be stored in an integer variable. This is very common actually. Declare a variable of type integer. here we called it length. We're just going to say it's equal to first name dot length, second name dot length. So pretty much the same thing we were doing before, but now we're assigning the value to a variable. And now we have size. So we've got the function size is the function length. So both the functions return the same value. So the syntax for the function size is going to be size, where the variable is going to be some sort of string type that you're running this particular method on. So as in the case of the length, the function has no arguments. It just returns the size, essentially. So why there are two methods? Because one of them is probably implemented in something else. Most people would use the length, actually. The size is going to return the same, essentially. But sometimes you'll see both of them being used. So find, this is interesting. So now we have a method that takes on a parameter to find an expression or find a sequence. So find searches a string to find a first occurrence of a particular substring, and then returns the integer value, size type, given by the result of the string. So the syntax is to say, give you your instance of this particular string variable, dot find, and then some sort of string expression. So this expression is the string expression that you're going to evaluate. You're going to find it in this particular string. And the string expression can also be a character, not necessarily a, say, if you want to find T in that particular expression, you put that in there. So if the search is successful, the find returns the position in which the match is found. So the return value is going to be like 6 if it was the T that we were looking for in that other example. And so if it's not successful, if it is successful, if it's unsuccessful, then it's going to return a special number of positions, not a position within the string. Instead, it returns no, like a false positive. So the following are valid calls to the string class. And so we have find this one inside of this string, find this, and what we've got here are strings plus, concatenating another string. We've got, with a character, with a string, with just a single character. So you can use it in all these different ways. It could be a single character or it can be a substring. So here's a string sentence and a string str, and then string. We're going to run size type position. So sentence is equal to cloudy and warm. String is cloudy. So here we can say in the sentence.find is, it's going to give us position 3, and is position 13, and we can go through the rest of it. It's just it returns a position number for where the substring is actually found. Now we have substring. So substring returns a particular substring of a string. So before we were finding a substring in a string, now we're asking for a substring because we don't want to use the whole thing. So the syntax is to run the dot substring with expression 1, comma expression 2. So expression 1 and 2 are expressions to evaluate the unsigned integers. So specifies the position within the string. So the starting point of the string and then the ending point of the string. So start with position number 2 and give me 5 characters or 6 characters or something of that nature. And here we go. Here's like 0, 5 gives it is, if we go out 5 characters from position number 0. So starting and then the number of characters. And 6 gives us cloudy from here, from sentence. So you can kind of see how it might be useful to return a substring, especially if you're trying to parse out some information that's coming in, and you don't want the whole thing. You just want the first and the last name are stored together, and you just want the last name or something, or the first name. And then we have the function swap. So let's say the person changes their name or address or something, and you want to swap what's in the string with something else. So the function swap is used to swap the contents of 2 string variables. So the syntax is to use swap is dot swap with the string value. So where the string value and string value are 2 different strings, so you're swapping one string for the other string. So here we have string 1 is warm, string 2 is cold. Well, we could just swap them. String 1 is now string 2. Down here on the bottom you can see it's kind of swapped. You use a swap. It comes in handy for some things as well. Let's ask if it's a vowel. Why this is in here, I don't know. Maybe for, what did they call it, Wheel of Fortune or something? Or those games that you can play. Is it a vowel? Or I guess a vowel or something. A-E-I-O-U. So is it a vowel? Checks and then returns true or false. Is it a vowel? Is it not a vowel? Rotate, I can think rotate would come in handy, and there's a ton of these little functions that are in the string class. So the function takes a string as a parameter, removes the first character of the string, and places it at the end of the string. So it's done exactly extracting string position at position number 1 until the end of the string is reached. So it takes the first, puts it to the last, first, second to the puts it to the last, etc. Until you end up with a reversed string. So it rotates the string. And you can kind of see and this is showing you the method implementation that's done. That's inside. You just call rotates, or you just call the method yourself. And things about strings. Let's take a look here. They're made up of individual characters, as we've seen so far. They're denoted by double quotes, as we've seen so far, especially with the array. Arrays are single quotes around characters. Strings are double quotes around a passage, like a message, more than one character. And they have invisible character at the end called the null character. We saw that when we were talking about arrays last week. And how many characters are in the word cat? 1, 2, 3, 4. So yeah, we have to count. We have to remember there's a 4th character on there. If we use it as a character array, if we don't use it as a character array, we don't have to worry about that. If we use it as a string, we just print the string out.
So for character array, there is no null character.
There is always a null character in there.
Character array also.
Only if it's a string. A character array is not going to put the null character in there. If you created an array and gave it 5 spaces and filled up all 5 spaces with characters, not a string, then you're going to have 5 characters. If you could put it double quotes, if you use the double quotes and you assigned a message, I don't know, the water, the cat, or something like that, you made that the string, you have to add 1 to it. The double quotes are going to put the null character at the end.
Like if you are assigning a string to a character array, then it adds a null.
If you send it as a string, it automatically puts the null character at the end. So you can take a character array and convert it to a string, and it'll put the character array on the end. See, because you have the double quotes here, this turns it into, it just automatically puts it on the end. This here you have to put it yourself. You have to add it yourself if you're going to use a character. And this is a character array, this is a string, actually. The difference is how you're populating the index values. So a string is an array of characters which contains a non-printed null character at the end with ASCII value 0 marking its end. So the string can be initialized in its declaration in 2 separate equivalent ways. And to answer your question, these are the 2 equivalent ways. So if you left this off, which you can do, you don't have to, you're not going to have a null character at the end. Because what you've done is created a character array. And this is a string. These double quotes is the trick. The double quotes puts a null character in there for you. You get the same end product either way you do it. It's just one is more automatic than the other. So, and you don't have to have it. If you're not going to use this as a string, there's no need to put that null character in there. Null character comes in handy though, especially if you want to use the functions to get the length. You want to get the functions to use anything associated with the string class to it. It expects the null character, and because it uses that as a checkpoint, so rather than having to do a for loop, it just says, well, until the item is this null character, do something. So character versus the string. A has a data type character and is stored in 1 byte. A memory address 5000. A is a string of 2 characters. So here's the difference here, actually, the single quotes versus the double quotes. Double quotes is always going to give you that null character. So it depends on how you assign it in terms of this method here. Character array, character array. If you use the double quotes, you're going to get that. Which is desirable if you want to use it as a string. Otherwise you can't perform any of the string operations on it correctly. So I recall that this message here, to the compiler, the value of the identifier message alone is the base address, which is in this case would be 6000. And it points to the memory location 6000. So if we gave it just the name of message and treated it like a string, it would tell us to start at memory address 6000 and go till we reach the null character, which is how we know it's a string. And we don't have to treat it like an array, because we already know we have a starting point is the name of the memory address that's stored for the name. So we can start at that memory address and go till we hit a null character, and then we know the string's done. So in terms of declaring a string, you can do it multiple ways. You can do it like a character array. And here we have a character array that's set to 255. It means you can have 255 characters in there, the size of the array. Or here we have a character array that's a pointer that's set to blah, 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 blah. So it's pointing to a space that's 15 big, dynamically assigned. Or we can put the brackets in here and we can dynamically assign it that way as not a pointer either. But you commonly see it like this. You'll commonly see it assigned as a pointer character because what we're doing is it's going to put this in here in the address space of this. So what ends up happening is we get it as long as this particular string is that we sent it, or we initialized it with. So both ways accomplish the same thing, but because both are pointers to memory, this is a pointer to memory, this is actually a pointer to memory. And this is different than using pointers in any other way actually, because if you followed character, dereference character, and you made it equal to this, then character is going to be assigned the value of the array, or the value of the string, I should say, in terms of the number of characters, which is 15 in that particular case. So reading this string from the user, so you can use cin to get the word. So we've created an array with a cin character array. We don't have to put anything, we don't have to go through, we don't have to loop through anything. It's not like populating every value in the array. Instead we just say send it to character array. And we can use cin get line if we want to get the entire line of the text, which is kind of interesting. This is going to get word by word. This is going to get the entire line. So we have spaces. Because strings have spaces. So normally variables don't have spaces in them. So as soon as it gets something, it puts the first item in. This is going to put the entire line in. Which is why, if you've ever wondered, why do we have methods on the object cin? Well, because we have get line, put line, cline. We have different ways of doing it. So we have a set with, or set w. So there's a danger in getting inputs. So the user can type in a string longer than the array that you've set up. Especially if you're doing a get line and your array is only 5 characters or 6 characters. So it might overflow. So as a result, the computer might crash, because especially if you're using a pointer, you're going to be writing past, or even if it's an array implementation, you're writing past the amount of space that's allocated. So you're going to go in somebody else's memory. So you can set W to solve the problem, which means read it in up to 255 characters. So you're setting the width. It ensures the input does not exceed the size of the array. So you'll see this, and you'll use this quite often to essentially, and you just use the set W of the width to actually print something out. Print it out using 5 spaces, which means if you wanted to have an entire column of information to print out correctly. And I believe we have a battleship game coming up in our assignments. I can't download it. I totally forgot to. Maybe I did already. I'll have to check at the end. But you'll be using arrays to keep track of players and ships. And I believe I did leave that assignment in. And you might want to use the set W to set the columns correctly, so that everything prints out in columns. So you can set the width of everything by a number of characters. And it pads spaces before it prints out the next one. So you'll see it when you start using it. Printing the string is very simple. You can use cout. Here we go, cout character array. Because when we do that, we're getting the starting address, and it's just going to go till it hits the null. So cout and cin actually work with the string class automatically for us. So it automates some of the behavior. And again, it kind of breaks the rules of everything. Because strings are treated differently in the language than character arrays or than other things in the language. So here are some more of the string functions, the whole library dedicated to strings. And this is just a small sample. String copy, concatenate, compare. Because you can't really say, if you did is this string equal to that string? It's never going to equal. It's never going to equal because you're looking at 2 different memory addresses. The string name always equates down to a memory address, and the same memory address is never used twice. So you're never going to get in a comparison, which means you have to use the string compare in order to actually do a comparison, which gives people some problems occasionally. So you can't compare this here. Here's actually the example. I kind of spoke ahead on it. String compare. String 1 never equals string 2. even if they have the same content, they're never going to equal because string 1 is 1,190 something, and string 2 is another memory address. These are memory addresses that you're comparing. So here's an example of doing string compare hello world. So you can do this. Say, are they the same? But it's not the same. Hello is bigger than world. So. String token. A token is a sequence of characters separated by some sort of delimiter, usually a comma or a space. So here's an example when in the course of human events it becomes, what are the tokens? Answer the words. These are the tokens. The delimiter is the comma. So we can actually do our own like parsing of the information in terms of the string. Helpfully, you read some information in from a result set you get from a database separated by spaces or commas or something. You read it in, you parse it out, use the token character as the space to divide things out with, and then all of a sudden you have an automated parsing system that parses a string out. So here's an example of the usage. So you pass null for each one of the successive calls, where we've got void main, character A, hello to the world. And we're going to have a character pointer. And then the token pointer is going to be equal to get. So you can take this character array that we've hello to the world and use the spaces as the delimiter. And then while it doesn't equal null, which means we have something, then print it out to the screen. And then notice the null. It's going to say, well, if it's the null, then we just print out, we end it, essentially. So you get hello to the world being printed out. And you can use null in this particular case, which is kind of interesting. Because you're not going to get anything. Null is empty, and it comes back with nothing. And it's going to come back with nothing if it doesn't find a match. So it returns null. Here's more code. Another way of doing it with E, let's say, as the end. So you get as the, what we did is the same example, but we changed instead of the space here. We use the character E, so it's delimiting it by E, so H-E, so we got H. And it doesn't print the delimited character, it leaves it out. So we have E missing, L-L-O, space, here's the other E here, and then we have world. It's not bad for parsing the input, I should say. So let's take another look here in terms of the concept, recalling that the compiler, the value of the identifier message alone is the base address. So reiterating that point, we say that it points to that particular address, so it points to that memory location. This is kind of getting you familiar with the use of pointers, actually. That's what the purpose of that is. So aggregate string operations. So we can do I.O. So I.O. is an entire string is possible using an array identifier and no subscripts and no looping. And it's done this way. We declare a message, it has 8 characters, and we say cin message, cout message. So strings, different from other arrays. We can do I.O., we can do aggregate functions on it, we can run methods on it, we can treat it like an object. It's implemented using a character array, but it's not like an array. So it has special qualities to it that go above and beyond the array concept. You can't do that with other arrays. Numbers and stuff, you have to use loop. And instead of, if let's say we weren't using strings and we were using integers here, we had to say for I is equal to 0, I is less than the size of the array. Get the value, get the value, get the value, get the value for each one of those index values. That's a lot more automated, think about it. And that's functionality that was built into the string class. So the extraction operator here with the double, which we're using with cin. So used to extract the operator to read in characters from the string variable. So it skips any leading white space, actually, and the characters such as white blanks and new lines. So when it succeeds, the read succeeds the characters into the array, it stops at the first trailing white space, adds a new character automatically. So this operator is what's putting the null character in when you're reading it from the command line interface. So if you go here and we read it in, message is going to have 9 spaces, not 8 actually, because it's going to have that null character at the end because the operator adds the null character to the end of the string. So here we have cin name from 5 here, and we typed in Joe, it looks like, total number of elements. and null characters added to the end. So we have 1, 2, 3 elements that were typed in plus 1. So we have 4 elements. So we have the function get, which is kind of interesting. And then what I'm showing you now is the CN options that you can use. So if you use the CN, you're going to get the entire word, and when it finds a white space, it's going to stop and put the null character in. If you want the white space, you're going to have to use another method. Otherwise, you're just going to go word by word. That's going to be entered in. So because the extraction operator stops reading at the first trailing space, you can't use it to put a string in that has blanks. So if it said, enter your first and last name, and you use this technique, you're going to get Joe. You're not going to get the last name. It's going to be left off. So to avoid that problem, you use the get. So if your string declaration size is not large enough to hold the input character and add the null character at the end, the extraction operator stores characters into memory beyond the end of the array. It doesn't know any better. So the same problem that you actually have with arrays in a non-string environment, you have with strings as well. Because you can very easily create a loop, and you said, this array has 5 integers in it, and add 10 integers through your loop. Which means you wrote into somebody else's memory space. Very unsafe operation, causes errors all the time, causes headaches for a lot of programmers. So use the get function with 2 parameters to overcome this obstacle. Get 8 characters. So here we have a message that only has 8 characters in it. So inputs at most 7 characters plus the null character at the end. So we use cn.get, and then the name of the array, and then the number of characters we want to get. This saves you from the headache of adding in too many elements and overfilling that array, which the compiler is not going to tell you about. Instead, your program is going to hang, or something really funny is going to happen to you. So, and that, I would say, you can use cn for it. It's both will work as long as the user puts in the right amount of characters. But if you want to make sure, you want to add like a special type of error checking and input control, then this would probably be the more effective way of doing it. But both options work. So now we have an in-file stream.get. Same kind of concept with a string plus the count of it plus 1. So the get does not skip the leading white space. The characters such as blanks and new lines are actually not skipped. So get reads excessive characters, including the blanks, into the array and stops when it either reads counts of the character, when it reaches the read count of the character, or it reaches the new line character, whichever one comes first. So get appends the null character to the string automatically as well. So if it's reached the new line is not consumed by get, so you don't put a new line in there, it just reads the new line and stops at that point. But the remainder remains waiting in the input stream, not captured into the string. So as an example, you're reading an input stream that's coming through, and there's a line return at the end of that line. It reaches the end of the line return, doesn't capture the end of the line return symbol, instead it just stops. Which comes in handy when you're reading stream data in, and you have this coming from, let's say, and stream data is going to come in from a file. You open up a file, you run an in-file stream, you get the characters of the file. And in most Windows programs, Notepad, stuff like that, you're gonna have this line return character at the end of each line. So this one is smart enough to recognize this character and stop, and go to the next line, stop, go to the next line, essentially, and not put that character in there. So ignore can be used to consume any remaining characters up to the end, including the new line return left. So we can say get the string, then ignore the rest, because we know there's a new line. We've word wrapped everything. It inputs 80 characters in this example. Skips at most 30 characters, but stops if the new line is read. And then ignore it. Ignore the new line, which means don't read it. So it doesn't leave it in the buffer. It just gets rid of it. Ignores it. It doesn't read it in. It doesn't put it into the string content, actually. And then get the string 2, and continue. Here's another example using the get. We have a character ch, then we have a character full name, 31 characters, character address, 31 characters. Enter your full name, and then we're going to get the full name 31. Okay. Get a character, Okay, to consume the new line. Because you're going to enter your full name. And then what are you going to do? Press return. It's like the old calculator. I mean the typewriter. You guys remember typewriters? Yeah? Have you guys seen a typewriter before? I was in it. You guys are graduate students, that's why. I was in an undergraduate class a couple of weeks ago, and I said, typewriter. And there were students in the class who had never seen a typewriter before. Of course, these students grew up with laptops in their cribs, you know, so they didn't know about typewriters. Yes, everyone remembers, you know, type, and you go, you push the wheel back with the right hand. And as a motion, I just did that a few minutes ago without thinking about it. I'm like, mimicking a typewriter. Uh-oh, that's wrong. I should be going like this. Return, return. I gotta change my hand motion to get rid of the swipe of the reel. Instead of the reel going back, I have to press a button for the return. So. But when you do that, it puts a line return in there. And you want to get rid of the line return. We don't necessarily want to read it. So this character right here, this statement right here gets rid of it. It reads it in, but it doesn't do anything with it. Enter your address. Enter the address. Get rid of the line return. So what it is you're getting in here is full name, address, and you've got the null character that's put in there automatically for you. And then we're consuming those lines. So the line, the forward slash and the N for new line is not appearing in your output. So here's some string function prototypes so you can get a feel. This is probably going to look Greek too, but if we were to write our own string class, which you can do, and some sadistic teachers have you do that actually, but I'm not going to have you do that. Instead, just take a look through at the string.h prototypes, and a string length takes on a parameter. It's a character. You know, string compare. It's going to take on two strings to compare, and you can kind of see, you know, which string copy is going to do a pointer actually. Copy one memory address to another memory address. So you can kind of sort of see how it's implemented. Some people are interested. Some people go, oh, okay, they just memorize the functions or the methods and go, oh yeah, this method, string compare, and then learn how to use it. So here we have another example with character author, 21 characters in it, and length. And we're going to see and get author 21 characters. That looks pretty good. And then the length of string length of author. What is the length? It's 21 characters. We have a null character, I think. Well, it's what did we type in? We typed in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think it's 11. Because we count the white spaces. It's not, and this is another thing that some students forget. This is a blank character that's actually puts in there. So it doesn't strip out any blank characters. So that would be 11, the answer to that question. And what is the output? So if we set as an example, my name 21 is equal to Huang. Oh, I said that right, I think. And then your name 21, and enter your name up to 21. String copy your name to my name. Okay. And here we have the same name. Oh, good. Else, or if it's the same, print it out else. If not, string copy it. Something comes before something. Something else comes before something anyway. If you copied it, we got the two names going on, and so we just switched them. So. And here we have my name is equal to your name. Compares the addresses only. And the addresses are 400. This is just reiterating the point that the addresses are 4,000 and 6,000 here. It doesn't really compare. But in this particular example, we use the string compare to look at it, and we had to use the string compare function to see if they were equal. You can't just say they're equal. I shouldn't say function, method call. Did you have a question, or was that just a pen? It was just pen. You? Just pen, okay. I saw a pen going. Alright. What do we have here? This does not compile either. What is the value of my name? What's the value of my name, actually? That's a good question for you guys. See if you're paying attention. My name or your name? That's it. Value of my name. My name. I think, well, the labels are underneath. It's 4,000. It's the memory address of the variable. So we're saying it's 4,000 equal to 6,000. It's never equal, as I was saying before. People will still try to do this, though. they'll make one equal to the other. Yeah, you're right. It's 6,000. You're right, because we got copied your name to my name. Now they're both equal to 6,000. They're both pointing to the same address right now, because we made one equal to the other, which is different than the comparison. And this is not going to work because it's a comparison. They're never going to match. This one we're doing an assignment of the memory addresses from one to the other. So we have essentially created what's called a dangling pointer, but you don't know about that yet. Because if we take your name here and we make it equal to my name, what happens to my original name? Now it's an inaccessible. Well, it's not a dangling pointer. I misquoted. It's an inaccessible memory address that we've allocated, but we haven't deallocated, and it's garbage. So we've created a piece of garbage in the statement because we took them both and had them equal to the same memory address. And what happened to the old address? It's garbage now. So it's unusable, actually.
String class implements the equal to operator, right?
No, it doesn't implement anything. Instead, you have to use the functions. You've got to use these functions here to make one equal to the other, copy one string to the other string, or to compare one string with the other string to see if they're equal. None of these operators work. The comparison doesn't work, and the assignment doesn't work, unless you want to actually make one equal to the other. But you've created, a piece of inaccessible memory at that point. Here we are overwriting the content. Oh, this is an interesting phenomena that occurs. So here we have get your name. Now string copy your name, my name to your name. So it changes the string your name, overwrites the content. So H is still the same. A, this one's different, this one's different, this one, that's all still the same. So it just takes the content and overwrites it. So. Using type define with arrays. This is the interesting thing that actually comes in handy because for some reason people don't like to use arrays. Or I don't know why. Some people are afraid of the subscript values. So here we have type define integer boolean. So names boolean as a data type, which is really of type integer. And then we have character, which is really a character array. Character 20 is an array type of 21 characters. And then we can say string 20 is equal to my name, string 20 is equal to your name, boolean is senior citizen. I'm going to go 1 or 0, because it's really an integer. And the type define is just basically redefining, taking this and making it into this. So we can kind of not have to worry about the, we can make it simple in terms of the naming convention. And type define does nothing more than a rename of one data type to another data type. It's useful with arrays only because you can get rid of all the subscript value notation. So write a program that will read in ID numbers, hourly wages, and names of up to 50 people from a data file. As an example I'm going to go through here. Then display the ID number, the hourly wage of the person in the file whose name is entered at the keyboard. Or indicate the person has not been located if that's the case. So. Assume that the data file looks like this. So we've got, those look like ID numbers and wages and names that are in the file. So here we have, we would tackle this problem because we know that arrays can't store, we still can't get rid of the problem that arrays can't store multiple different data types. So we have to have parallel arrays set up. So we set up parallel arrays that hold related data. So we have the maximum number of people is 50, and now we're going to take one, define a data type, and the data type is going to go to string string 20. And we have 3 different parallel arrays. One's an integer, one's a float, and one's a name, because we have the ID numbers, the wages, the salary, I guess, and the name. So it holds up to 50 strings with each up to 20 characters plus the null character at the end. So, and then we basically, at one moment in time, there's our data from the data file. As we read it in and we used it. And then we can use, in terms of the parallel array example, we can use, like, say, index 0 to be all the data associated with Dale Nil. And then, all these other names are associated with the other index values. So it's a nice way of taking index values and associating it with items, sort of like a database, if you think of it that way. So in terms of using an array of strings, here's some more examples. And what we're looking at here is functions, prototypes. So we've got get data, handle requests, lookup. So we can, following along with our same example, we can write a program here to hold up to 50 IDs. So we have integer, floats, and strings again, along with the number of people. And now we can create functions, essentially, where we can actually, when we send the information to the function, we can automatically change it. So we can, populate the array, get the IDs, do all sorts of different automations with it. So get the data, handle requests, and then end the program. So in terms of the model, we've got the main menu. We've got our data for our get data, which is going to be in those three: numbers, wages, names. We got our handle requests that are going on. This is pretty much what this program is doing in terms of this model structure. Numbers, wages, persons. In terms of getting it, these are our functions that we're going to use to look up to see, is that person in here? Add the person, otherwise look it up to see if the person's in there. So. And here's our implementation of these particular functions, and you can kind of see how we can use the arrays as function parameters, send the entire array. So if you want to get the data, we send the ID array in here, along with the wages array and the strings, for the names. And then we can read it in from a file. So this actual code works, actually, so you can cut and paste it, put it into some files, compile it, and run it if you want. And actually see it work. You have to recreate the data file, obviously. But you can read in, create an ifstream object to your my file, open it up, attach it with a .open file, a .open method to open up the file. Read the stuff in, and essentially, if you follow through the code, what it's basically doing is all of the things I've shown you in the examples a few minutes ago, ignoring the null character at the end of each file. And this is where you can kind of see where you need to consume that new line character. Occasionally, it comes in handy. Otherwise, when you open up the file, you get all these new line characters that are going to be stored in that data. And you're populating arrays with it. So if you put a new line character in an integer array, as an example, you're going to get an error message. It's not going to work. So, because it's going to say, wrong data type. Can't put a null character, and it comes in as a null character. A new line character, excuse me. And you're going to data mismatch error. So just ignore it. Don't read it in. The function to handle the requests using a similar syntax as before. And here you might notice from a review from a previous lecture I gave you, if you missed it, the keyword constant. What's that going to do?
Cannot change the value.
Correct. Yeah, good. So you guys remembered. So it makes it so there's no side effect. So when you read that array in, looks like we're reading it in. Oh no, we're entering or populating it. It's not gonna change the array. So what goes to Vegas stays in Vegas, essentially. Otherwise, what goes to Vegas in this example is going to change unless we make it constant. So. And we'll see the keyword constant used when we start creating classes, I believe, next week. When we start doing inherit, because I'm going back to inheritance next week. So we've had a little break with arrays, but inheritance next week. So lookup, is that the other function? So precondition, postconditions that we can check on that. Ways to improve efficiency of searching process. So if the array names were sorted, let's say, the sequence search for one name could be aborted as soon as a single name was greater than some sort of a dictionary order. Or you can probably, if we had a sort of list of names, we could find a character that matched, like, first name started with B. Skip, go to the B's, or stop after the B's if you've already found something or haven't found something. So if the array names are sorted, a faster type of search called a binary search can be used instead of the slower sequence search. So in terms of the sorting, it means arranging the list into some order and looking at if it's a list of array items, if it's looking at any type of data structure outside of using a class to do a linked list, you've got an order because you have index values 0 through something. This requires copying the contents of one array to another array because you have to essentially change the order, or within the same array, reorder the contents, which may or may not necessarily be time consuming or time effective, I should say. So for instance, here if you have strings in alphabetical order, for numbers ascending or descending order, you can easily find the information. So the selection sort process, what you're going to do is examine the entire list to select the smallest element and then place that element where it belongs with the 0 array subscript. Examine the remaining elements and say if it's going to be the smallest element from there, then you can order it from smallest to largest essentially, and then place the element where it belongs, number 1, number 2, number 3, number 4, until you get all the way up to the end essentially. Examine the remaining 2 elements in the list, select the smallest one, then place that one where it belongs. So if you had names 0 through 4 through the first pass, you'd say, well, this one comes up here, he gets put up here, and this guy gets put down here. So then we got those 2 switched around. So you keep swapping them until you get the array done. So this is for pass 0. And here's our selection sort. So if we sorted the array items, and how often you do this, well, it depends on how often you're searching it, and how often it gets updated, I should say. You only have to resort it once on every update. Because what ends up happening, well, you could sort, you can't dynamically change the size of an array though. That's the problem. There's limitations with this, which is why it's probably better to use a linked list. Because if you have let's say you have a list of 10 numbers, you can't add an 11th number to it. And you certainly can't insert it in the middle of the list. You have to resort the entire array to put it in there. So, which is not so efficient. So arrays for searching and for sorting. For searching, okay. Sorting, you can do minimal sorting with it. Not what I would call the most efficient data structure for list processing, but it can be used, and it is used for a lot of simple lists. When you get beyond that, when I'll talk about it in terms of the implementation of pointers, you can create what's called a linked list using pointer variables and basically create your own dynamic array. So you can take same array concept, but make it so you can insert items at any position in the array and automatically sort things or not have to worry about sorting things. So it makes the find and the search a lot easier. Because you're not going through index by index, you're not looping anymore. Instead you're using memory addresses. And you can sort the memory addresses any way you want, associated with the pointers. So if you wanted to do a binary search on an ordered list, examine the elements in the middle of the array, and you cut it in half. Then you go for one side or the other side, and you cut it in half. One side or the other side, cut it in half. Kind of a faster sorting technique. This is classic binary array algorithm. You repeat the process on half the list again, and you stop when you find the section that it belongs in. So here we can pass the array to this particular function for a binary search, and then use inside of the function a loop to go find, actually if you know the index value by the size, and say, well, there's 50 items, then see if it's less than or greater than item number 25. If the item is less than, then you know you only have 0 through 25 to work with, or 24. So, and then you break it down, break it down, break it down. And here's the sample code that would be used to implement that particular process. So if it's found, then it's less than, otherwise say it's not found, or greater than. So, here's the trace of the binary search, and I didn't really go through the algorithm, but this is primarily you're interested in knowing you're examining index values, and you're using the index values as the search order. So that's where, if this is a sorted list, you can actually go, find out what the index value for half of the list is, and then find out the value is going to be smaller than or bigger than that particular number. So. And that was everything I ever wanted to know about the concept. I didn't go through the algorithms in a lot of detail because this really isn't an algorithm course. Rather, it's more of it's supposed to be object-oriented programming in C++. So, but I did need to cover arrays to a certain point. Because arrays, it's kind of interesting to compare arrays with linked lists in terms of that concept. Thought I'd just see. Hello. Computer is, there we go, it's thinking. Let's see what the computer's going to do. We're thinking. Oh! We got pointers, which is number 7. This is the one. Okay, so we are actually up to the pointer category, so I'll give you the option for next week. And looks like I could either start pointers today, Or I could start inheritance today. What do you guys want next week? Inheritance or pointers? Inheritance? Pointers. I heard pointers. Pointers. Okay, maybe raise hands. How many people want pointers next week? Nobody? How many people want inheritance next week? Oh, inheritance? All right, let's go back. Okay, let's finish the second part of this lecture then. I can do it right now. Because whatever I start this week right now is going to determine what we finish next week. That's what I was asking about next week. All right, last time we got to, let me just make sure. Yeah, let's go down memory lane. We started in a couple weeks ago, before I started talking about arrays, and we started talking about classes, and we learned the topology, the C++, and the .h. We learned about the driver program. We learned about the class rules in terms of public and private, and we learned about the skeleton, how to create the attributes. We learned about the constructor as well. Designing the constructor, the driver. We went through an example that used pointers, actually, in terms of creating, without using the keyword new. Instead, we used pointers to create. And then we learned about new. And in this particular example, we did both. We created CDOG, C1, and we created C1 is equal to new. And we said new instance, which is going to be used for dynamic memory. We already looked at the concept of what we were doing when we were allocating those objects. We looked at adding methods. We looked at the operations between using pointers and using variables with these two particular operators, the dot notation used for regular variables, and this is used for pointers. And accessors and modifiers as a concept. And we talked about the second header file that goes along with the C++ files. And then we stopped right here. And this is the part that we're going to cover today, just to get back up in the terms of the concept. So now that we're back, after our trip down memory lane, most of you are probably looking at this going, I don't remember any of that stuff, but we don't. We covered all that stuff, if you were here or not. Let's talk about inheritance. It allows us to take one class and make another one from it without having to reinvent the wheel. So we automatically get everything the previous class had. So we're talking about subclasses and superclasses in this model, sometimes called a parent-child relationship. And we use the class name to express this relationship. And we'll see that in a few minutes. So the subclass will inherit certain attributes and methods, benefit, good design, reuse of code. Let's talk about a hierarchy. And this is the basic concept. And if you've had this Java class, it's the same kind of concept, but it's implemented just slightly differently. Instead of using extends, we use different syntax, actually. So we have a mammal, and I guess I didn't spend too much time going over that previous example, but it was about creating dogs. I believe we had CDOG. We didn't have really anything else. So here now we can kind of think about the hierarchy and say, well, we have a mammal class, and the mammal is going to have a weight, and it's going to have a give birth method to give birth to new animals. So we have land animals as one of the categories. I guess we could have another branch out here for sea animals, or for wind, flying animals, I guess birds, cats, dogs, and fish, sea animals. And we have a dog. A dog is a land animal, and the dog is going to, well, we gave a rabbit or no rabbit in terms of its whether it had the disease rabies. So that's what that meant. And now we can have two types of dogs. We have a Chihuahua, is that what it says? A Chihuahua and a sheepdog. So the question, how many attributes does dog have? How many attributes would dog have, actually? That's a good question for you guys to answer. Let's see how much we remembered. Well, see how much we can kind of get from this chart. Well, it's going to have rabbit, right? Three attributes. It's going to have rabbit, number of legs, and weight. So inheritance allows dog to have 3 different attributes. Otherwise, dog would normally have just one attribute. So what you don't want to do is give dog 3. You want dog to have its own, whether it's rabbit or not rabbit. Use the weight, use the number of legs from its inherited class, assuming we're going to apply some inheritance here. We haven't seen how it's done yet, but we know we're going to try and create this hierarchy. So things to note. Land mammal is a superclass to dog, but a subclass to mammal. So this is a superclass to dog because it's above, but it's a subclass to mammal because it's below it. So a class can be both a superclass and a subclass at the same time, which land mammal is in this particular case. And dog has 3 attributes, as we saw before. It has weight, number of legs, and rabid. 2 from inheritance and 1 that it declared itself. So here's an example here of CDog, and this is just review, so we've seen this before already. We have the CDog, we have some public methods, weight, character name, those are all, that's a string now. And a Boolean rabbit, and it has a default constructor, and it has another method to growl. So the dog can pretty much growl, it can't eat or do anything else yet, but it can growl. And that's the .h file, by the way. And in the .h file we have the function prototypes, and they're actually written in the same function prototype as when you write a function prototype. It has a semicolon at the end of the function declaration. And here we have a cdog.c++. This is still review. We've done this already. We're going to include cdog.h because that's our function prototypes and our methods and everything that we're going to put in here. And then we use the scope resolution operator, if you remember, to say inside of cdog, for cdog, this is the default constructor that's taking on, or I should say the constructor. If it were the default, it wouldn't take on any parameters, but this one's taking on integer x, which is going to be the weight, I believe. Yeah, here's the weight. So this constructor is rewritten here, or it's implemented here. So C++ they call the implementation class, and this is they call the specification. Some people call it specification because it's the .h. So also in our implementation we're going to say that we're going to copy the name Bob to name. So CDog has been made. And then we're going to implement growl, and this is scope resolution operator. It says inside of CDog, implement growl. So now we have a poodle. It's the evil subclass of dog. Because poodles are evil. So, since a poodle is a type of CDog, okay, how can we make a class poodle without rewriting a lot of the code? So now we're going to inherit. And unfortunately, this is a evil poodle inherited from a dog. So, does the poodle necessarily growl the same way as CDog growls? Well, if the CDog is a German Shepherd, probably doesn't. Poodles, they go around yiping. Yipe, yipe, yipe. Irritating little dogs. I don't like poodles, actually. So here's our class poodle. Both header and C++ file together. So we have a CDog. We're including, this is kind of different from Java, actually. We don't have to include this, but we don't have to include the C++ file, we just include the .h file, which is our header. So now we have class C poodle colon public C dog. So here's where we inherit from C dog. We have this constructor C poodle, and C poodle is going to be our constructor where we're inheriting from C dog everything because we did colon public C dog. Not as straightforward as Java. It's nice to say, class C poodle extends C dog. Or that would be, in fact, that's the Java syntax for the same thing. A little bit more self-explanatory, but here we have, this is the new class we're creating, and we're going to say colon public C dog, which is giving us our inheritance, believe it or not. And so now we have, inside of C poodle, we can write the method for C poodle, the constructor that's also going to overwrite C dog x. That's going to say a poodle was made instead of a dog. So what's going on in here? Let's take a look at this a little bit more in detail. So the normal constructor stuff is going on inside of this constructor. The superclasses constructor is always called. this particular case, we called the constructor, which makes an integer. So we have to say cPoodle constructor. It's calling the cdog. All in the real world, when these classes are actually being executed and instances are being made, every one of these constructors fires, unless we overwrite it. Here we're overwriting it. We're calling the cdog constructor and saying, instead of making a cdog, let's make a cPoodle. So we're going to print to the screen that poodle was made instead of a dog. So in terms of this notation here, if you don't explicitly call the super constructor, it looks for no argument constructor in the superclass, which we don't have, and we'll run that. If we had it, it would run it, actually. Because what it's going to do is going to run a constructor from each one of the classes, similar to the same functionality that happens in Java. Every time you subclass a class from a class, all of the constructors fire off. But in this case, we can overwrite it, change the behavior, if we don't call it. If we don't call it, it's going to look for it, which we don't have, so we don't have to worry about it. But if we had it, it would run it, which we may not necessarily want that behavior to happen. So we created a poodle that has all of the attributes and the methods of a cdog. So cdog has, here's a problem here, cPoodle pointer, my poodle is equal to new cPoodle 3. We gave it away to 3. My poodle growl prints girl. Poodles don't growl, they yipe. Because we didn't overwrite that. In fact, here we didn't mention growl at all when we wrote it. So, but we called growl, which we can do because we get everything. We get all the methods and we get all the data members of the underlying class that we inherited from. So we get all the cdog stuff. So we can actually call growl. So we can override the methods. So if we don't override the method, the original method works. Same true for the constructor. So when you override a method, you give the new functionality to the class. In this case, we need to override the growl method for the poodle, simply redefining the method. So here's a better poodle. It now goes yipe, 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 yipe. Actually, it only does it once. Yipe. I don't know any poodle that does that. Poodles go yipe, 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 yipe. Irritating until they stop. So. What are we doing here? We're doing cPoodle growl. So now when we run growl, it looks for it in the current class. If it finds it, it runs it. If it doesn't find it, it goes back up to the base class and then runs it from there. So we just, by creating a new one here, we override the old one. So if we don't redefine it, we leave it alone, we get it inherited. If we want to change it, we redefine it. We just add it again. And we're not going to get an error message because this is inside a cPoodle. This isn't inside a cdog. So we go from cPoodle growl. We can't change cdog's behavior. Cdog is always going to growl. We can only change it from cPoodle, which is kind of a mistake actually. A lot of students kind of end up going into there. But it's not in cPoodle. It's inherited from into cPoodle, whether you want it or not. So let's talk a little bit about the access keywords public and private. So you can restrict access to the attributes and to the methods inside of the class using public and private. Public means everyone can see it, private means only the class can see it. So if we made cdog growl private, it stays inside of cdog. So here we have a bad example. It won't compile actually. Because we have class X, and inside of class X we have a private myInteger, and we have a constructor and stuff. Now here we've tried to print out myInteger. It's not allowed because it's private, because everything's private. So we can't access it from the public, essentially, if it's private. And we change it to public, and then now we can access it out there in the main public. So why private? Security keeps all the classes from changing attributes at random. And for design, forces other classes to use accessors and modifiers to get the information. And for encapsulation, so the class is not complete in itself. You have to get and set the weight or the rabbit. You can't actually do it outside. And then if you want it to be private, but you want classes to subclass it, then you make it protected, which is, do we have protected in Java? I can't remember. I think we do. Yeah, it's the same rules as Java then. So if a class that says cPoodle wants to change something and you don't want to make it public and you don't want to make it private, you make it protected. That way cPoodle can change cdog stuff and access cdogs of data members and stuff, but the public can't. But inherited classes can. Here's the memory trace where we've got create a couple of dogs here, D1 and D2. D1 is equal to a new dog, 5 Bob. And we have another D2 is also equal to a new dog. And D1 is equal to D2. Well, so both equal to the same memory space at this point. So we have one object out there. And D1 and D2 are both pointing to the same object out there. So remember, new opens up the space and calls the class constructor. Actually creates it. Here's D1. And now we have rabbit is equal to false, weight is equal to 5, and name is equal to Bob. And remember now, new opens up D2. We have that. Now D1 is and D2 do not occupy the same space in memory, so they are not really equal. So D1 does never equals D2, so it evaluates to false. The same reason why the pointers in the string implementation of the string class, you can't say one string, does one string equal another string in terms of the comparison. This is what we're doing, the comparison operator. This never works either. So we can't really say that D1, although we've made two objects, they're not really even of the same object. We're not doing, instead we're comparing the memory addresses again. So getting back to that concept I mentioned earlier about strings and the equality. Can't do it with strings, you can't do it with instances of classes either, of objects. Objects will never be equal to each other. Even though they're the same, they're never going to be equal. So let's see what we got here. Now D1 is now equal to D2, and what have we done? We've created another memory leak. So we have a piece of memory out here that's basically inaccessible because we can't go back to it because we have D1 and D2 both pointing to the same memory address, which is kind of wasteful. Java cleans it up for you automatically. In C++, it stays for the entire life of the executing program. No automatic garbage collection. So because no one is pointing to this, it can no longer reference this, so we can call this piece of memory garbage. We killed it, but we haven't allocated, we haven't deallocated it. We haven't run a delete on it, which we haven't seen yet, but we haven't run a delete on it yet. So it's out there, it's hanging out there, but we can't access it. If we did this in Java, we would be fine. So this is one of the downfalls of C++ versus Java. No automatic garbage collection. And we have garbage. So freeing up the memory is necessary to get rid of the unused memory. Rule, never set to null. Otherwise you got rid of the memory address. Use the delete operator. And so here's the introduction. So we've seen new, we just haven't seen delete yet. So it takes to a pointer to an object, and usage from the previous example, delete D1. But we have to delete it before we move it back. So we use the delete. We'd use the delete on D1 to delete the object, and then we take D1 and have it equal to D2, or have D1 equal to null. If we set D1 equal to null without deleting it first, we still leave it there and cause the same problem. But we'll see delete actually used in a couple of different examples. So summary of the inheritance concept, the benefits of inheritance allows us to reuse the code, good design. So use the class name to achieve this. Override the methods in the superclass, in the subclass, and then test the same object in memory. And it's going to be in terms of the inequality or the equality. So we got some choices. That was the inheritance option that you'd selected on earlier. I'm still not going to cover pointers today. I think I'll wait till next week on the pointers. We have C++ object-oriented concepts, or we can leave early today, about 15 minutes. Half the class left already. So I'm going to take option number 2 myself personally. And then, so someone remind me next week. We're doing object-oriented programming, and then we're going to hit pointers. Everybody's favorite topic. Because this is only about 30 slides, I believe. This is not that far. This is pretty much. We may not get to, we might not get to pointers, but we might. Who knows? But I'll say that for next week. So we're still on lecture number 3, this third part. You can remind me. You can remind me today, I think. And then eventually we got to hit pointers. Pointers is not too bad. I got an entire lecture 6, I believe, on pointers. I'm just refreshing my memory to see. Not bad. The only thing is it's different. You don't get this in Java class, so it's brand new to you. Some of the other stuff we've had already, you've heard about already in terms of concept. No, it's not number 6. So it must be lecture 7. Okay, so we're done for this week. And so next week, object orientation, pointers. Thanks for staying, those people who stayed. I don't know why we lost half of you guys today. Maybe the lack of internet access. Okay, see you next time.